Alright, let's introduce the non-inverting amplifier, and if you look at the configuration, it's pretty much similar to the inverting amplifier with a couple modifications. Okay, we do notice the difference is if you look at the non-inverting, okay, terminal here, it's actually, that's where we're going to apply our input voltage, okay, as opposed to the inverting as we applied it over here. Okay, so that's the one main difference here. We still have our feedback resistance up here, and we still have our input resistance here, if you will, or R1. Okay, so essentially what's happening is this is grounded here, so the ground and the input voltages are in reverse. So let me go ahead and write this down. Okay, the input and the ground are switched, okay, compared to the inverting op amp. Okay, so that's the main thing between the two. Okay, so now we can apply KCL. And we know that we see here that we have I input is going to equal to I output, or I1 is equal to I2 in this case. You can name it whatever you'd like. So we know I1 equals I2. Okay, that's going to give us 0 volts minus V1 for I1 over R1 is equal to V1 minus V output over RF. Okay, but right now we know, again, for an ideal op amp, V1 equals V2, and in this case that's also equal to the input. Okay, so we can substitute this knowledge into this equation here, and we get minus V input over R1 equals V input minus V output over RF. Okay, and just make a note of that here. This is our relationship, but we can rewrite this in terms of just V output equals 1 plus RF over R1 times V input. Okay, so that's a different form of this relationship. Okay, so again, our gain, let's pull up just a little bit, our voltage gain A sub V is equal to output over input, which is that equation we just came up with, 1 plus, or part of it, RF over R1. Okay, so that's another way of looking at this relationship here for an non-inverting amplifier. That's what we're looking at here. Okay, and a couple things to know about this non-inverting amplifier. We note here that the gain is positive, so gain is positive. Okay, that's the non-inverting name. And this amplifier retains the infinite input impedance of the op amp. Okay. One thing to note is the gain can never go below 1. So let me go and put this 1, because we got this 1 here. So one aspect of this amplifier is that it cannot go below 1. Okay. Another thing to note, what we can do is we can replace the feedback, so we can replace this feedback resistance with a wire. Okay, so we can do that. If we do this, minus plus, we got our output here. I can replace the feedback resistance with just a wire, and we got our voltage source here, the input. Okay, of course all this is grounded. Okay, plus minus, our V output equals our V input here. And our gain would still be 1. So replace RF with a wire, and the gain would still be 1. And this has a specific name, this configuration. This configuration is called a voltage follower, or a unity gain amplifier. A voltage follower, or a unity gain amplifier. And it's good for separating two circuits while allowing a signal to pass through. Okay, so that's one potential application of it. So this is the non-inverting amplifier, and the equations given to it here. So let me go ahead and highlight this guy here. So V out equals Vm.